I've seen people measure perfectly and still make dangerous decisions. Let's talk about the 3 core measurements that pretty much every newbie gets wrong. We'll start with voltage. Voltage is a very simple measurement. You take your multimeter and you place the probes between 2 different points, and what you do is you measure the voltage difference across those 2 points. The assumption that oftentimes newbies make is that 0 volts means that the circuit is safe and there is no voltage flowing through and it's safe to work with, safe to touch. No. This goes really back to my previous video where I talked about my friend who got shocked really badly just by making this same assumption that seeing 0 volts across the live and earth, it means the circuit is safe to work with. Always remember why you're measuring. Think about why you're measuring. Because when you realize that you're not just measuring some number, when you realize that you're measuring a difference between 2 potentials, that's when you will start looking at this measurement differently. So, advice to, just like to my friend and everyone else, measure multiple points. Do not only measure live and earth. Also think about maybe there's a shared neutral which can carry current from a different circuit that you're not even measuring. So also measure live to neutral and also measure neutral to earth because there could be some leakage current going out of the circuit. So remember that voltages measure differences. You are measuring the different potentials between 2 points across your multimeter. That's about voltages. Now currents. Current is also a very interesting one because when you're just clamping some conductor, you're effectively measuring the current that flows through the conductor. And the assumption here that newbies make is quite similar. It is seeing 0 amps on your clamp and assuming, okay, the circuit is dead, so I can just touch everything. No. Also think about things like capacitive coupling. So there are capacitors potentially inside of the circuit which can still carry energy, and because they're not actively being discharged for whatever reason, it still doesn't mean that they cannot, on some point in time when you're starting to touch live conductors, that they can discharge their energy through you. So be very aware of these kind of things. Also be aware of leakage currents. So advice to you, maybe also clamp the neutral and also see what kind of current is flowing through the neutral. Same story as with voltage. The neutral could be shared from another circuit that you're not even measuring the live conductor for. So always be aware exactly what you're measuring and why you're measuring it. Current actually shows and tells a big story about imbalances and hidden faults. So think about this, think about what you're measuring, also clamp the neutral, just stay very safe. And the third one, and this can be quite a surprise to some of you, is about continuity. So continuity, once again, you take your multimeter, you put it on 2 points, and you either hear a signal, a beep, and I can demonstrate right here. So this is just with the multimeter, and I will take my 2 leads and I will put them together. So that means that there is connection from one lead to another. And you can imagine if I take one lead and put it on one point of the circuit and another, if those 2 are connected, that's when you're going to hear the beep. If they're not connected, you're not hearing anything. So the assumption, of course, here is if I hear something, if the beep is happening, it means that there's perfect continuity. Well, not really, because high resistance paths, so paths that have high resistance through them, will also beep because there's also continuity. And also remember that corrosion also could still beep, because if there's connection, there's connection. The multimeter doesn't see or think about any of these things. So be very aware and be skeptical about your measurements. And when you're thinking like, okay, maybe I'll just measure the resistance across 2 circuits, or across 2 points rather, it is also actually quite misleading because you have connected circuits. So it means that there's also some resistance parallel to what you're measuring, and you're not really measuring the real resistance. So resistance measurements are not really a solution to this, because resistance measurements only make sense if the rest of the circuit is basically known to you. What is actually much better to do is to measure the voltage drop when your system is under a load. So when you're loading the system, measure the voltage drop. This is a much more accurate measurement in terms of continuity and also in terms of resistances. Now, to conclude all of this, I would say the biggest mistake isn't measuring incorrectly. It's actually believing that one number, that 0 volts, that 0 amps, or that beep tells the whole story, because it is almost never the case. And so this is only true for those who know exactly what they're doing, because they are measuring exactly 2 particular points in a circuit or a conductor, and because they know exactly what they're doing, that number tells them a lot more than, well, what newbies would assume and oftentimes just get shocked or draw false conclusions. So be aware, number 1, what you're measuring. Be aware, number 2, why you're measuring this. Always have expectations of what you expect to see, and also be very aware of what the rest of the system could do or what it looks like, and be open-minded and always think in terms of double checking things. So also clamping the neutral, measuring the neutral to earth, not only live to earth. These kind of assumptions will make your life, number 1, a lot more easier, because you will see more results. You will always have this certainty that you're measuring the correct things, and then you're actually getting the correct results. And number 2, it'll make your life a lot safer. So be aware. I hope you enjoyed this video. I'll see you in the next one, and keep measuring things. Bye-bye.